Welcome. In this video, we'll be evaluating the following indefinite integral you see in front of you. So this needs to be rewritten as the limit as t approaches infinity of, and then I'm going to replace one of these limits of integration with t, namely the one with the infinity. So from 1 to t of 1 over 1 plus x squared dx. In the next step, we integrate, but the limit will remain out front. This is simply tangent inverse of x evaluated from 1 to t. And if you don't see how I obtained this integral, please look up here. There is a video that I made that you may have watched already if you're following along from my Canvas course or YouTube channel. So if you've seen it or you understand how to integrate this already, you don't need to watch this video, but in case you don't see that step, please click on that video link. Now let's continue to leave our limit out here in front and evaluate at the limits of integration. So we have tangent inverse of t minus a tangent inverse of 1. So we can split this into two limits. It's the limit as t approaches infinity of tangent inverse of t minus the limit as t approaches infinity of tangent inverse of 1. Now we need to recall a little bit of trigonometry here. So as you can see, I went ahead and sketched the unit circle here. We're going to use the unit circle to find out what tangent inverse of 1 is. This is just a constant, and this limit of a constant will give us a constant. So that's what I'm trying to figure out here. So if you recall from either pre-calculus or trigonometry, tangent inverse of 1 will give us some angle. And that angle is limited between negative pi over 2 to pi over 2. So you only want to explore angles that start here and go all the way out this way. So from negative pi over 2 to pi over 2, and we don't want to include these actual endpoint angles. Now where in quadrants 1 and quadrants 4, where is tangent of an angle equal to 1? If you said pi over 4, you are correct. So now I have that this is the limit as t approaches infinity of tangent inverse of t minus pi over 4. Now to evaluate this integral, we need to review a little bit more trigonometry. Namely, we need to review what the graph of tangent inverse of x looks like. And this function, it has horizontal asymptotes here and here. Take a moment and see if you can figure out the equations to these asymptotes. So this one's y equals something, and this is y equals some other value. If you said y equals pi over 2 and y equals negative pi over 2, you are correct. So we can see here that as t approaches infinity, tangent inverse of t, well, what does it approach? As we go out on the x-axis forever, it gets closer and closer to pi over 2. So tangent inverse of t approaches pi over 2. All right, well, this means this entire limit is pi over 2 here. So this is pi over 2 minus pi over 4, which simplifies to just pi over 4. Since this limit here evaluates to a finite value, we know that this integral is convergent. I hope this video has been helpful.